is for students who are in grade 3 and in grade 4. Now, before we start with our today's masterclass, let me just quickly introduce myself. This is Neha Chauhan here. I am a teacher expert at Cuemath with a teaching experience of more than 3 years. The subjects that I primarily teach are mathematics and reasoning, and the regions that I cater to are India and US. Now, before we start with our today's masterclass, what you need to do is to grab a pen and a notebook so that if you feel that there is something important which you have learned in today's masterclass, you can quickly take that down for your future references whenever you are revising this particular topic. With this, we'll start with our today's masterclass. So the first thing that we need to do is to see what all are we going to cover in today's masterclass, for which the topic, as you all have already seen, is embedded figures. So let's see the table of contents. The first thing that we would do as usual is understanding the concept of embedded figures. Then we'll see what are the applications in our day-to-day life of embedded figures. We'll see what the objectives are, which will be setting the types of problems that we'll be solving in today's masterclass, which also makes it very clear to expect what sort of questions come in Olympiad level exams or quizzes or talent searches. And once we'd be done solving the basic level problems along with the advanced level problems, we'll go towards the learning outcomes, which is basically the takeaways. That is what all have we understood from today's masterclass. So the first thing that we need to do is to understand the embedded figures concept or the definition. So embedded figures are figures hidden inside another figure. Okay. So basically what you can imagine or how you can understand it is, you have a pattern in front of you. So that is a parent figure, the main figure which you have. Now inside that main figure, you may have different shapes. So each shape which is forming the pattern for that main figure is called as an embedded figure because that is present inside it. It is a part of that whole picture. So if you have a picture wherein there are mountains, so mountains are embedded inside that scene, inside that picture. So you have a bigger picture inside which there will be small different patterns, small different shapes or lines. Those are all called as, which constitute, put together, the whole picture are called as embedded figures. So as we are going with the definition, it says a figure is said to be given like X and followed by 4 complex figures and also given by which you need to find the similar figure X in the 4 given figures. Now, to be very, to make it very easy for you all to understand, let me just give you a quick example. Let's say we have a scenery like this, wherein we also have some mountains. So these are some mountains that we have inside this, and then we can have a river flowing through the mountains, and then we can have some grass over here. Now, if I was to ask you, is there any shape or is there any figure inside this scenery which is circular in shape? The answer to which is no, because we nowhere see in this scenery a circular shape. So because the circular shape is not present inside the scenery, we would not call this circle to be an embedded figure for this particular figure. Whereas if I was to ask you, do you spot any shape which is of this type? So you would definitely say yes, because we have all of those mountains in this shape. So this shape is an embedded shape to this scenery. Again, if I was to ask you, do you see a shape like this? So you would say yes. So this shape is also an embedded shape to this given scenery. And then we also have the river, which is forming a part of this scenery. And so that also is embedded inside it. So basically, if you spot a similar figure inside a main picture, a bigger picture, you would call that smaller part to be as an embedded part or an embedded figure inside the bigger picture, probably hidden or might not be hidden. It might be, very evidently seen to you, that you can, just have a look at it and you can spot it. So this is basically the concept of embedded figures. I hope all of you would have understood. Now that you have understood, let's have a quick test of whether we are able to solve such type of questions which are based on embedded figures. So here it says, identify the correct figure in which figure X is hidden. So basically what we have here is a question figure, which you see is this. and we've been given with 4 options. Now we need to find, you know, uh, any of these 4, is it present in the question figure? Do we have any pattern or, anywhere in this question figure shapes similar to this? That is what the question is. So I can find this semicircular kind of an arc, and then I can find this, but there is no one more, just on top of it. So we can say that option 1 cannot be the correct answer because it's nowhere embedded in question figure. Now, if we were to go with option 2, let's see, we can trace an arc like this, then we can trace an arc like this, then we can trace another arc like this, and then the fourth arc like this. So yes, we do have, a figure which is there in option 2 exactly embedded in the question figure. So option 2 can be one of the correct answers. Now, if we were to go with option 3 again, the arcs are present, but these 2 arcs are pretty much closed. So this would not be the correct answer. And nowhere in, in the question figure do we have, one arc on top of another circle as close as this. So this also is not the correct answer. So basically the only correct answer which we have found, which is an embedded figure to the question figure, is option 2, because it was exactly following the same pattern as we have in the question figure. And that's how you solve problems which are based on embedded figures. Hoping that all of you have understood this question, we go on to the next part, which is called as the applications. So like I've already told you, like where you can relate to embedded figures, you can have your carpet in your home when there are patterns inside your carpet. So each shape, each pattern which is made in your carpet is an embedded figure, is an embedded shape. So that is one real life example that you can take. Now, when coming to applications, one of the most important applications that we see is camouflage. Now, I don't know whether most of you do understand the meaning of camouflage or not. Camouflage, if you were to speak, is mostly used in armies. When we have soldiers who are protecting our borders, they wear clothes of, of the terrain that they are of in the geography that they are in. Like let's say the soldiers are in an area which is full of forest, which is full of trees. So they would be wearing clothes, their uniform would be as such, which would exactly be matching um, the geographical pattern, which is mostly made up of trees and grass. So if somebody from the top, let's say from an aircraft or from a satellite, if is trying to spot human beings on ground, they would not be able to spot them because they are getting exactly embedded in the geographical pattern. So what are they trying to do? They're trying to protect themselves from the enemies by getting themselves embedded exactly into the geography that they are in. So basically, like if they are in a terrain which has got more of trees and grass, we see them, we see the soldiers. I'll just draw it out for you all. So it basically is of something like this sort. I'm just drawing one pattern out of it. It has, it would have leaves like this on their uniform. So when they wear that uniform and when they're there in that terrain, if you would have a satellite, if you would have an aircraft trying to watch them or spot them to aim them, they would not be able to find soldiers because they're completely embedded into the geographical terrain. Now, where did we understand, where did armies get this idea of having camouflage like this? So basically, if you all would be watching National Geography, or if you would be watching a Discovery, you would see that a lot of animals, have got their body patterns exactly the way their environment is. And that way they can hide themselves in the environment so that nobody eats them away. Okay, so you know about this prey and predator concept in in ecosystem, that there are animals who eat away other animals. So the ones who want to protect themselves, they try to camouflage themselves, they try to hide themselves in the environment itself, so that nobody is able to spot them and then eat them away. We have some insects which completely look like leaves, but they're not leaves. They're basically, insects. We see chameleon. So chameleon changes its body color with respect to what its environment is, and that's how it hides itself from other animals who can eat it. So these are some very real life examples and applications which we see of embedded figure, wherein you can or animals or soldiers do hide themselves to protect themselves. Now let's see some more applications. General problem solving. Exactly what I said. In buildings, in architects, in patterns, you'll be able to see social behaviors, problem solving style, defense mechanism. Just as I told you, what insects and animals do, what soldiers do, they camouflage themselves to protect themselves. And then solving puzzles. So solving puzzles is basically jigsaw puzzle, if you would know. Jigsaw puzzle is like basically a one big picture which has been split into, which is broken into parts. You have to connect all of those parts, those jigsaw parts, and once you connect all of them, a bigger picture is formed. So that again is based on the concept of embedded figures. With this, we come to the part of objectives. So there are two objectives based on which we'll have the questions, the problems which we'll be solving. The first one is, it says identify a small part hidden in the given figure. So you have to identify a hidden part in the given figure. The second one is identify the figure in which the given part is hidden. So basically you would be given whether you'd be given four options wherein small parts would be given. You have to choose which of the small parts is there in the given figure. That's objective one. Objective two is identify the figure in which the given part is hidden. So you'll be given just one small part, and you'll be given four main pictures. So you have to choose amongst which of those four main pictures that small part is present, is constituting the is a part of the main picture, the bigger picture. We'll solve such problems, and then you'll be you'll get a better clarity of how to go about these type of questions. So here is our first question. So it says here in the given question, find the figure from the options which is hidden embedded in figure X. So what we have is four options. We have to choose which of these small parts which are shown here, small figures which are shown here, is a part of figure X. So what we will need to do is we'll need to first observe and see if it is present. So the option A has got one straight line like this, vertical standing line like this, then a sleeping line like this, and then a slanting line like this. So here we have a straight line, a sleeping line, but then after this there is no slanting line in this direction. So we cannot say that option A is present anywhere in this given figure X. Option B also is not present anywhere, because if you would try to trace out similar such shape inside this figure X, we would not be able to trace it out anywhere. Same goes for this, because it has got a sleeping line or a horizontal line like this. So if you were to trace it out, you go like this, then you come a bit down slant ways, and then it has to go this way, but it is nowhere going like that. So option C is also not the right answer to our question. Let's see option D. So it has got a slanting line like this, which we also have in our figure X, then a horizontal line, then a vertical standing line, and then we have a horizontal line again like that. Then coming down, we have a straight vertical line and then a slanting line. So it is exactly the way we have option D. This shape which we have traced out is exactly the shape which we have in option D. So option D is the embedded figure in figure X. So the correct answer to our question becomes option D. I hope all of you would have understood this question. With this, we'll move on to the next question. So it says here, which of the following parts is exactly embedded or hidden in figure X? So the first one is, a bit of tilted rectangle. So nowhere in this figure X do we have a bit tilted rectangle. Let's see for option B if we can trace that out. So there is a vertical straight line like this. So we can have it here, or horizontal straight line like this. Let me just go a bit straight, which is like this, and then it comes slant ways down, and then it goes slant ways forward. So it is exactly what we have traced out in our figure X. Option B is exactly the same shape. So option B can be one of the correct answers. Now let's see if we have option C anywhere. So we do have this V sort of shape, but there is no vertical straight line coming out of it, in the middle of it. Or else if you were to check it here, there is a vertical straight line like this, a slant line like this, but then there is no one more slant line like this, so that it would match with option C. So option C is not the correct answer. And again, nowhere we have two horizontal lines like this, in between which there is a shape like this in the figure X. So the only option which we could trace out in the figure X was option B. So the correct answer to this question becomes option B. With this, we move on to our next question. So you all can also try answering these questions in the comment section. If you feel that you've already understood and if you already know the answer, please do put it in the comment section. And if at all, if you have any queries, you can also put that in the comment section and we'll be answering to those queries and doubts. Now it says we have to figure out which option has the given shape exactly embedded without any rotation. It has to be present in the same format. You don't have to rotate it, clockwise, anti-clockwise, upside down. You don't have to rotate it anyway. It has to be present just the way it has been given in the question. So let's go one by one. We'll go first with option A. So we have a horizontal line like this. This has a straight slant line here and here as well. But if you were to check, nowhere from both sides, it is coming straight way down. It is a bit curved line. These both are curved. So this is not the correct answer. Coming to option B, we have a horizontal straight line, a slanting coming down. Oh yes, and then from this side also, and then curved line like this and curved line like this. So yes, option B is one of the correct answers. Coming to C, we can easily rule this out. Why? Because this part which they have shown us in the question has got two curved lines, whereas in option C, there are no curved lines at all. So it will definitely not be embedded in this. Same way, we can easily rule out option D because this also has got no curved lines. So the only correct answer to this question becomes option B. With this, we move on to our next question, which says, which option has the given shape exactly embedded, again without any rotation? So you have to have, any of these options present inside the main figure which is given in the question without any rotation. So let's see. We'll go with option A. So we can basically see that there are two rectangle sort of shapes attached together. So let's see. So we do have two rectangles here attached, but these are horizontally lying rectangles and these are not exactly the way it is. So we cannot consider option A as the correct answer to our question. Then B, we do have a shape which is like this, exactly what is given in option B, but option B also has in the middle a straight vertical line like this, which is not there in the figure, in the main figure. So option B cannot be the correct answer. Option C is exactly the way what we have traced it out here, option C. So option C can be one of the correct answers. Option D, again, we can trace it out at the bottom of the figure, which is here, like this. But again, to bring to your notice that here there is a straight line like this in the middle, which is not present in the main figure. So option D also cannot be the correct answer. So the only correct answer that we have in this question is option C, which is an embedded shape inside this main figure which is given to in our question. So I hope you all are enjoying. This is an easy, fun topic today. All you need to do is to spot whether a small part is present in the main figure or not, or the small part is present in which of the main figures. So it's quite easy. It's just about your observation, if you quickly are able to observe it or not. We move on to the next question. It says, Which of the four options has part that exactly matches the given figure? So we have a triangle. We need to figure out from the four main pictures that in which of the main pictures this triangle is exactly present. So the thing to understand here is that in the first one, we do not have any triangle which is of this type, this shape, which is standing like this. It has got triangles. If you were to look at it, it has got this triangle, but it is not in the orientation exactly as the one which is given in the question. So option A can be easily ruled out. Then in option B, we have exactly the same type of triangle in the same orientation as to how it is given in the question. So this can be one of the correct answers. Coming to option C, we do have a triangle like this, but if you would see, it is the other way around. It is facing the other side. It has got a different orientation to it. It is not exactly the same as to what is given in the question. So this cannot be the correct answer. Coming to option D, we have a triangle like this, but if you would look at it, this triangle has got this side a bit longer than the other two sides, but in option D, mostly all of them look a bit, of the same length. They're not very different. So this cannot be the correct answer. You have to have exactly the same shape as to what is given in the question. So the correct answer to our question becomes option B, ruling out A, C, and D. With this, we move on to the next question. Again, we have a problem figure. We need to find this problem figure is present in which of the following options. So we can clearly, rule out option A because it has got this sleeping line, but it has to have two slanting lines coming like this, which is not there. So we can easily rule that out, option A. Option B again can be easily ruled out because this has got this thing. It has to come down this way. And after it comes down this way, it has to have another horizontal line like this and then a pin attached to it. So easily ruled out. Option B cannot be the correct answer. Okay. Coming to option C, again, we cannot trace out a figure which is exactly same as the problem figure. So this also is ruled out. Now coming to option D. There is a horizontal line here. So exactly the same way we have a horizontal line here. Two slanting lines coming down, same way as it's given in the problem figure. Again, a horizontal line as is given in the problem figure, and then a pin sort of it attached to it. So this is exactly how the problem figure is. So this is the figure in which we have the problem figure as an embedded part. So the correct answer to this question becomes option D. This is how you have to answer these questions. All of these questions are really very easy. All you have to do is to be a little bit of more focused and pay some attention while you're observing the parts and the main figures, so that you're able to trace out the exact same part in the options or in the main figure. Okay, so moving on to the next question. So it's the same thing. You've been given with the problem figure. What you need to do is you have to check all of the four options, and then you have to tell that this problem figure is present in which of the options. So what we have is an arc, a curved line like this, and then a slant straight line passing through it. So this is the problem figure which we have. Now we need to check by going through all the four options that it is present in which of the options. Easily we can rule out option A. Why? Because there is no curved line in option A, but we have to have this curved line. Same way we can easily rule out option B because this also does not have any curved line to it. Then coming to option C, we have a curved line here in the same orientation and then a straight line passing through it. So option C can be one of the correct answers. Coming to option D, we have a curved line like this and there is a straight line passing through it. So if you would see, it looks a bit similar to what is there in the problem figure, but the difference is the orientation is different. The shape or the part which we have traced out right now is in this orientation. It's like it's been flipped. So it's not exactly same what is there in the question. So this also would not be the right answer. to our question. The only correct answer to our question is option C. So as you all saw in this question again, all you need to do is to pay some attention, to have a little bit of focus and observe and try to trace out the problem figure in the given figures. If you're able to trace it out exactly the way it is, then that would be the correct answer to your question. Moving on to the next question. It says, so we have, the problem figure is basically an n, and we need to trace out whether any of these four options has got an n to it, exactly the same way it is given in the problem figure. So let's go with option A. So here there is a vertical standing line, a slanting line is coming down, but then again there is no vertical straight line going up like this. Nowhere we can do that. So option A cannot be the correct answer. Option B has got these two standing lines, but the slant line, is going the other way around. It's going from left to right, and that too from bottom to top. What we need to get a slant line is, it should be coming from left to right, but from top to bottom. You see, this is from top to bottom, it is coming down like this. So option B cannot be the correct answer. Same thing is there with option C. Okay, if you were to take these two straight lines, or if at all, if you were to take these two main boundaries as the vertical straight lines, again the slanting line is in the different direction. So this also cannot be the correct answer to our question. But coming to option D, if you take these two outer boundaries as the vertical straight lines, we have a slanting line in the same direction as it is given in the problem figure. So this figure, which is option D, has got the problem figure as an embedded part to it, which is an N. So the correct answer to our question here becomes option D. So I hope you all are understanding today's topic. It's fairly easy as we've been solving so many problems already. There was nothing much difficult if you would look at it. All you need to do is do tracing out. And if you are familiar with patterns, jigsaw puzzles, you would be able to do it real quick and real easy way of doing it. So with this, we move on to the next part. Okay, so it's the same thing. It says here, which of the four options exactly matches a part of the figure here? So we have a main figure here, and then in the options we have been given with small parts. What we need to figure out is whether those small parts are present in the main figure or not. So starting with option A. In option A, it is A. Do we see an A anywhere in this figure? Can we trace it out? We do have two slant line like this, but then there is no horizontal line which is connecting these two slanting lines, just as we have the alphabet A. So option A cannot be the correct answer. Then we have a W. So we'll have to have two vertical standing straight lines. So we have one here, but we cannot find another, a parallelly, just opposite to it, another standing line like this. So option B also cannot be the correct answer. Coming to option C, we have a vertical straight line, then a slant straight line going up a bit and then coming down. So it's exactly the same way the part is given in option C. So option C can be one of the correct answers. Then is an N. So again for N, we have to have two vertical straight lines like this, and the two ends must connect like this. But we nowhere have, two vertical straight lines opposite to each other in this given figure so that we could form or we could trace an N. So this also cannot be the correct answer. So the only correct answer is option C, which we could easily trace out. With this, we move on to some advanced level questions. So here is our question number 1. So all of you can, start answering it if you already know the answer to these questions in the comment section. We will be picking out the right ones. It says, which of the four options exactly matches a part of the figure here? So we have a main figure which is given to us, which is this. This is the main figure. It has been made up of different subparts, as you all can see, different sorts of triangles. We need to figure out from these four options which is present inside this figure as an embedded part. So the first one is, it's a vertical straight line coming all the way down like this. Are we able to trace it? We have a vertical straight line here, but it's only till the mid, and then we will not be able to trace out this other part of option A. So option A is not the correct answer to our question. Okay, and then coming to option B. So a vertical straight line like this, we trace that out, sleeping line and then slant line. Yes, we could trace this out. So option B can be one of the correct answers. Then let's see if we can trace out what's given in option C. So there is a horizontal line like this. Slant lines are coming like this, but this is getting connected here. It's getting joined here. It's forming a vertex. Whereas we need to have a side here. After the horizontal line, there are two slant lines. And then at the bottom also, they're connected by a horizontal line and they're not directly connected to each other. So it's not the correct answer. Now, if you were to check the last option D, so we have two slant line like this, sleeping lines coming like this, but they have to go slant ways up like this, which is not happening. So this cannot be the correct answer to our question. The only correct answer to this question is option B, which we have already picked up. So this is how you solve this problem. Moving on to the next problem. Okay, again we have a main figure here, which is this. We need to find which of the following four options is present inside this main figure. So the first one has got a slant line like this and then two triangles attached to it. So we have this slant line in the figure, but nowhere to, on the top side or at the bottom side of it, we do not have triangles attached like this. So option A cannot be the correct answer. Coming to option B, it's got this slant line. So there is this slant line, then straight line, then sleeping line. So we could trace it out till here. But then it comes vertically down and then there is a horizontal line as to what we see in option B. But that's not what's happening here in the figure. So that cannot be the correct answer to our question. Option B is not the right answer. Coming to option C, we have straight line like this, sleeping line, vertically standing line like this, but it comes slant ways like this. It has to come slant ways like this for it to match with option C. That's not happening in our figure, main figure. So not the right answer. Option D. Okay. So it has a vertical straight line like this. So we have it here, a sleeping line, and then a vertical straight line going down. So it's exactly matching the option D. So the correct answer to our question is option D. So this is how you can solve these problems. With this, we move to the next part, which is the learning outcomes for today's masterclass. What all we learned is tracing out the alternative figure which contains figure X as its part. We already saw a lot of problems where we did the tracing. Tracing is what we did in almost all the questions to understand which part is embedded or the given part is embedded in which figure, and then carefully observing the options to find out the hidden part in it. So we've done that almost in all questions. It's like, the other way around of going it. Either the part is given, you have to spot it is present in which figure, or the figure is given and you have to, from the parts given, you have to pick which part is an embedded figure. So it's the solving of the problem remains the same. The method of doing it remains the same, is basically observing, trying to trace out the small part in the main figure. If you're able to trace it out, then that is an embedded figure. If you're not able to trace out a particular shape or particular pattern in your main figure, in the problem figure, then that is not an embedded figure. So I hope all of you learned of how to tackle these type of questions which are based on embedded figures, and answer them correctly. So with this, it's a wrap for today's masterclass. For all parents and teachers who want their children to get enrolled for TUCO, TUCO has already started taking registration. The way to register, the details that you need while you're registering your child or your student for TUCO would be given towards the end of this masterclass. So stay tuned and get all the details and all the information that you require for registering your child or your student for TUCO 2020. So as we all saw in today's masterclass, how logical reasoning inculcates the ability to think logically in a child, they start thinking in an innovative manner. They also strive to get to the answer in the shortest possible way. And this is exactly how a student gets trained by a Cuemath expert, and all of it is being provided in Olympiad masterclasses by Cuemath. So with this, I would like to introduce the TUCO registration forms. Every student who wishes to take up the real-time Olympiad examination by Cuemath, please go ahead and click on the link given in the description box below. The registration amount for TUCO is rupees 200 only, and the benefits that you get on registering for TUCO is that you get a complete course curriculum to prepare for it, which is worth rupees 5,000. So every time we have a masterclass, an Olympiad masterclass as we had today, which is scheduled, you can join us there and then later can work on extensive sheets on the same topic through the course curriculum provided when you register for TUCO. So make sure you do not delay and register yourself to get the most out of the curriculum worth rupees 5,000 just for rupees 200. And with this, we'll be winding up today's masterclass.